All right, everyone. At the time of filming this, it is currently 104 degrees out with a feels like temperature of 111. So, that said, that won't stop me from talking about custom extensions because I'm super jacked up about this. So, let's actually hop in the tech and show you exactly what we can do. So, in case you missed the last video breaking down OS query and custom extensions, here's the brief recap. So, OS query, which AI query is obviously built off of, contains 278 tables out of the box, which provides a wide array of flexible, stateful information that can pertain to a whole host of use cases. However, what happens if you want to gather information that's not contained within these 278 tables? Well, that's where extensions come into play, because as the name suggests, they extend the capabilities of OS Query beyond the 278 tables by essentially functioning as its own table. So an extension you can think of as a custom-made table. So super powerful because it essentially changes the scope to literally anything you can think of, from homegrown application auditing to checking configuration files of what you have in your environment. But the only problem is they tend to be difficult to manage at scale, and on top of that, unless you're proficient at coding in languages like Golang, they tend to be difficult to create. But that's where AI query comes into play. So how does AI query help? Well, let's take a step back to the prior example from the last video where I said, just brief example, I wanted to gather the information of Chrome updates by pulling this updater.log. Well, there's not a table for that, so if I cat out that log real quick just to see its contents, we can see it is a very verbose log with a ton of information that's roughly structured. It's more kind of semi-structured rather than key value pairs, which would be nice and convenient. But what we can do is we can actually just take a little snippet of this log and then feed it into our AI extension generator and have it generate a nice verbose Golang, a programming language of which I know nothing, extension file. So quick caveat, this is not actually going to be talking through the AI extension generation, as that's still to come. We still have to add that in the UI, and I'm super pumped to make a video about it. But right now it is fully working through the API, so that's actually what I use to build this extension. But I'll make a whole other video about actually AI custom extension creation within the UI. So here we actually have the Golang code that was generated from the sample of that log, and we can see here it uses regex to parse the log and generate the applicable fields. So once we've crafted the binary, which we've already done, what we can do is we can pivot on over to AI Queries console, over to our new custom extensions section right here, and go to create custom extension. So the very first thing we're going to want to do is give it a title and a table name. So we'll do AIQ Chrome Updater, and we'll just use the same one for both. But again, this table name is what you're going to reference the select star from this table name. Specify the compatible operating systems. In this case, I'm just going to use Mac OS and just use my personal Mac as the example because it's quick and easy. And then we'll update the binary extension that we have created via our AI assistants. Then we'll hit next, and that will upload the binary. So as a quick caveat, obviously I created this using our own AI, but one of the other reasons I wanted to mention this binary upload piece is that there are tons of great resources out there. If you pulled an extension from GitHub or various other sources, you can actually just upload those right to our UI and then manage the deployment across your entire environment instantly expanding the scope of OS Query's capabilities through AI Queries management. So next piece here, we're on preview where we have the project title and table. The next thing we want to do is check out the schema. So what we'd actually do here is if it was AI assisted, once we add that into the UI, we will actually auto-populate all of this for you based on the code. But since we uploaded a binary, whether it's a third-party binary or one you created yourself, you actually have to specify the schema. Again, you're effectively just dictating what the table is. But it's not required. We're not going to go through in this video just to try and save time. This is more for your own internal reference because it'll still work accordingly in the binary. So we're gonna skip through that because I'm lazy to save some time, but then we'll move on over to testing the extension. So again, if we hadn't already built it, we can actually build right here within our console. But we already uploaded a fully built binary, and all we want to do is specify our testing device and hit deploy extension. So I selected my personal Mac right here, and as you can see, deployment queued, waiting for agent. And we should see results momentarily, and there we go. Deployment log successfully deployed. Perfect. So now we've confirmed that it was successfully deployed to that machine. Now we actually want to test the extension that we created to confirm that it is actually extracting the information that we're hoping to before we publish and make this a production-ready test. You can actually think of this testing page as almost a sandbox because basically what it does is allow you to get a quick overview of what the query results might look like or anything like that before having to deploy it across your environment. So quick sandbox test, this actually won't persist on this device. I'm just deploying it for testing. It'll undeploy after. But we can see right here the actual results, and it's not going to be the full query results, and it's not going to show up on the query results page because once again, this is a sandbox, and we're going to restrict the results to just a quick sample to confirm, yes, this is extracting information from the log just like we're hoping, which is perfect. That means we're good to go. So now that we're good to go, we're going to hit publish, and what that will do is it'll actually publish the extension. And if we go on over and check out view custom extensions, we'll have two tabs, our drafts. So if at any point during that process I left that page, it'll be cached and saved as a draft, so you don't have to lose any valuable progress. But in this case, we published it. So here we actually have the example of the published extension, which we can click into, see the compatible operating systems we specified, any schema that we have created, which once again, I was too lazy to do so for this video. But when you create a schema, this is where you can reference it, and then deployments, so you can see where it was actually deployed to. And you may be asking yourself, well, hey, Nick, I saw you deploy it to your machine. Why isn't it there? Because once again, that was a sandbox environment, so it's actually localized for testing just to confirm that it works. Now that it works, let's manage the deployment at scale, and we can do it for a whole host of devices. But on this one, we're just going to specify the same device just to keep it nice and simple, and click Deploy Custom Extension. And then we'll see right here we have options for all the available published custom extensions. And then here we can see the AIQ Chrome Updater. You can select any of these, and they're not mutually exclusive, so you can have a bunch of extensions or unlimited extensions on any device. But in this case, we're just going to specify our Chrome Updater extension and hit Deploy. And then if we pivot back on over and check out that extension once again, we can see if we go to deployments, that deployment was a success, and once again, we have the log reference. So now we've gone ahead, we've created the actual custom extension, we've given it a title, we've tested it, we've uploaded it, we've tested it, we've published it, and now we've deployed it. So last step, let's go ahead and actually query it, and so we'll do select star from AIQ Chrome Updater, and then we're gonna go ahead and say Chrome, I can't spell, Chrome Update logs, and then we're going to specify my device right here. And let me just fix the Chrome spelling because that would be embarrassing after I called out how I can't spell. Of course, it's not spelled right after. So run it just like a normal query, and if we hit refresh here, we have results right away, which is perfect. So let's check out what we got for results, and we can see there are 6,242 total results across 313 pages, which is awesome. And so I don't know about you, but the first thing that jumps out to me personally is actually the structure of this, because if we look at the original log file, this, again, it's semi-structured data. It's difficult to parse through if I was trying to find a specific element. However, here, not only is it centralized, so of course I just did it on my own device, but let's say I had a whole host of devices. I want to go ahead and I can query this across all those devices, extract that log, but not only that, I have these specific elements that I can then filter on. Right? So I can specifically filter on the timestamp or on the actual severity level or anything of that nature. And on top of that, what I can do is I can use the built-in filtration to specify keyword matchings within these items. So again, it just breaks that log into the semi-structured data into fully structured data that we can analyze accordingly. So if I wanted to, I can go ahead and look at message and just look for anything that contains the word fail. There we go. And we'll hit apply, and we can see we have 192 results, drop down a lot as if we're looking for specific failures. And then we can actually see the severity. If we wanted to, we can actually filter one level further and specify severity equals warning. So let's just remove those. Or if we wanted to, we can do and not equals verbose. We'll do not contains verbose. There we go. Just as an example of a not operator, so we can see we have 96 results, so cut that down drastically, and now we can actually search through any of these potential failure messages and see if any of them are worth investigating further. So the actual breakdown of the specific log is relatively irrelevant. That's not the point. The point is, here's a random log file that is semi-structured data that I'm not able to gather anyway. However, I can create a custom extension for that. Not only does it break into nice little pieces, but it makes it so I can centralize from one location, gathering of this information across my environment, perpetually moving forward. So that's the power of custom extensions. It is really just that extending the capabilities to anything relative to your unique environment. So whether it's a configuration file, whether it's a log file, whether it's any sort of semi or roughly structured data, create an extension for it, upload it, manage it in our console. You don't even have to think about it again, and now you've just extended the capabilities so you can troubleshoot with ease at scale and save yourself a massive amount of time. In case you can't tell, I'm super jacked up about this capability. So if you had any specific ideas for any custom extensions, please let me know. I'm happy to do so. I've just been creating these left and right all day. But stay tuned for the additional videos that I'm going to post here, which actually break down some of the actual AI pieces, which I'm super excited about. And yeah, until next time, stay cool, everybody. See ya.